Very quickly, we look at potential divider circuit. When we talk about potential divider circuit, you know that when resistors are arranged in series, resistor with resistance R1, resistor with resistance R2, and they are connected to a power supply of EMF E. The resistors, the PD across this resistor will add up to the EMF of the circuit. Therefore, we can say that this circuit is actually a potential divider circuit because the voltage across this resistor is being shared. That means the EMF of the circuit is shared as voltages across the resistor. So this constitutes a potential divider circuit. So I can say that a potential divider circuit consists of resistors arranged in series and connected to a power supply. So according to what we said before, this battery supplies current I. Current I flows through resistor R1. Current I also flows through resistor what? R2. So we can say that the PD across R1 is IR1. And you remember that the current in the circuit will be given as the combined EMF of the circuit over the total resistance of the circuit, which is basically R1 plus 1 R2. So if I substitute this into this equation, the PD across R1 becomes what? R1 over R1 plus R2 times E. Similarly, the PD across R2 will be given as R2 over R1 plus R2 times what? Times E. So if you have resistors connected in series to a power supply, you should be able to recognize that it's a potential divider circuit. And you can easily use the potential division equation to find the PDs across the separate resistors. For example, calculate the PD across the 6 ohm resistor in the circuit shown below. So here, I have a 2 ohm resistor in series with a 6 ohm resistor, and the voltage of the battery is 16 volts. I want to find the PD across the 6 ohm resistor. The PD across 6 ohm resistor becomes 6 over 6 plus 2 times 16. This becomes 6 over 8 times 16. This will give you what? 12 volts. So in finding the PD across the 6 ohm resistor, I don't need to first find the current in the circuit. Then find the PD across 6 ohm by saying it is the current flowing through the 6 ohm resistor, which is the current in the circuit multiplied by 6. No. So in the same way, if you are getting the PD across the 6 ohm resistor to be 12 volts, then the PD across the 6 ohm resistor will be what? The PD will add up to what? EMF of 16 volts. So this becomes 12 volts plus 4 volts will give you 16 volts. Okay? Another equation. The PD, another equation, a voltmeter of infinite internal resistance is connected across resistor X in the circuit shown below. The voltmeter reads 4 volts. Calculate the value of resistance, of resistor X. So I have this. Okay, and this is actually this is 20 volts. So this question basically says that a voltmeter is connected across resistor X. The voltmeter is having an infinite internal resistance. It's having an infinite internal resistance, showing that it's an ideal voltmeter. Ideal voltmeter basically means that the voltage reading there is exactly the P across X. Okay? So we now want to find the resistance what? X. Remember that these two resistors are in parallel and their combined resistance is in series with this. So this is a potential divider circuit. And the combined resistance in parallel is basically, if you have two resistors in parallel, the combined resistance is the product of the two resistors over their sum. So this becomes 6 times 6 over 6 plus 6. This is 36 over 12. That will give you 3 ohms. So I now have 3 ohms in series with what? With X. And the P across X is 4. So using the potential division equation, I have 4 is equal to X over X plus 3 times what? 20. What do I do here? I cross multiply. That becomes 4x plus 12 is equal to 20x. So if you collect like times, I'm going to have 12 is equal to 20x minus 4x. This becomes 12 is equal to 16x. So x becomes what? 12 over 16. And this is basically 3 over 4, which is 0.75 ohms. Okay. So that are some of the useful application of potential divider circuit. And when you are using the potential divider circuit, be sure that this power supply has an infinite internal resistance. Be sure that the power supply has an infinite internal resistance.